Jai Hind all. Myself Yogendra Prajapati. I am the professor of the Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to discuss cache memory, its mapping and numerical problem. This is the very important topic asked in the university examination and different type of the competitive examination like GATE, NET and other examination. Before discussing the numerical problem of the cache mapping, first I explain the basic overview of the cache mapping, different type of the. What is the cache mapping? Cache mapping is very small type of the mapping which is designed between the processor and main memory. It used to mainly increase the higher speed of the cache mapping. The cache mapping is very costly than the other memory, so that the size of the cache mapping is very minimum. The cache mapping is extremely fast type of the another mapping, so that the importance of the cache mapping is very important. It holds the frequently requested data and instruction so that immediately available to the CPU when it is needed. This is the main feature of the cache mapping. Cache mapping is very small memory, extremely costly and extremely fast. Now this is the block diagram of the cache mapping. Cache mapping are designed between the CPU and primary memory. This is the main configuration of the cache mapping. It is very extremely costly and extremely fast. This is the performance parameter of the cache mapping: hit ratio and miss ratio. These are the two parameters of the cache mapping. Hit ratio, when CPU want to data access into the cache memory, if data is found in the cache memory, then that is known as the cache hit. If data is not found, then this is known as the cache miss. What is the cache mapping? This is the important topic, and different type of the numerical question asked in different examination. These three different type of the mapping: direct mapping, associate mapping and set associate mapping. In direct mapping, it is the very simplest technique. Direct mapping map each block of the main memory, into only possible cache line. Each block of the main memory are directly mapped into the cache memory. Such kind of the mapping is known as the direct mapping. Now this is the diagram how to understand the cache memory. This is the main memory of the cache mapping. This is the tag, or this is the word offset. Tag is represent the number of the block available into the main memory, and the word offset the number of the word are available in each block. That is the configuration of the main memory. When the data of the main memory are mapped into the cache memory, then tag are divided into the two part: tag offset and line offset. What is the tag offset? The tag offset is the number of block available into the cache memory. And what is the line offset? In each block, how many number of word offset can be accumulated? This is the line offset. This is also known as the index of the cache mapping. And what is the word offset? Word offset are the same into the main memory and cache memory. In set associate mapping, means is the combination of the direct mapping and associate mapping. It means the every number of block of the main memory can accumulate into the cache memory anywhere. This is the known as the associate mapping. Now, this is the block diagram of the cache mapping in associative mapping. Similarly, tag are divided into the two parts, tag offset and set offset, and word offset is equal into the main memory and cache memory. Now, we move from the numerical problem. This type of the problem is asked into the GATE examination and other examination, university examination also. Now, question: a logical address space of the computer system is consist of 128 segment. What is the logical address? That is the tell about the size of the cache memory. 128 number of, this is about the cache memory, and each segment can have 32 number of pages. And what is the word size? 4K word. It means how many number of blocks can be available into the cache, that is known as the 128 divided by 32. I think this is the 4 number of block available into the cache memory. Four number of block available into the cache memory. Okay. And in each, and what is the word size? Word size is 4K. What is the 4K? 4 into 10, that is the word size. Physical memory consists of the 4K number of blocks. Now, this is the size regarding the main memory. And what is the main memory? And what is the size of the main memory? That is 4K number of block of 4K word each. Okay. Now, how many number of block are available into the main memory? That is 4K. That is 4K means 4 into 10, 24, that is the value of the K. It means 4096 number of block available into the main memory. Calculate the logical and physical address format. What is the logical address? What is the format of the logical address? Logical address and physical address. Physical address format are divided into the two part. Tag format, that is the physical, that is the tag. Now, this is the word offset. Word offset. What is the tag represent? The number of the block available into the main memory. And how many number of block available into the main memory? That is 4096. It means 2 to power 10. 2 to power 12 bit available into the. And what is the size of the each word? That is 4K. Again, it means 2 to power 12. That is the word offset, and this is the block offset. It means that is the 12 bit and that is the 12 bit. That is the physical address format. And what is the logical address format? It means these number of blocks can be accumulated into this cache memory, so that in each pages are divided 32 number of blocks. It means what is the 32 number of blocks? 4096 divided by 32. It means 128 number of block available into the number of block available into the main memory and 4 number of block available 1 2 3 4 into the cache memory. 128 number of block into the main memory and 4 number of block available into the cache memory. It means these 128 block can be accumulated into the 4 number of block. It means how many block can be available into the cache memory in each blocks? That is 128 divided by 4, that is 32. It means 32 number of blocks can be accumulated into the single blocks. 32 number of blocks can accumulate in this block, 32 number of blocks can accumulate in this block, 32 number of blocks of the main memory can accumulate into this cache memory. 128 number of blocks can accumulate in this format. Now, what is the logical address? How many number of blocks available into the cache memory? 4. It means that is 2 bit. And how many number of pages can accumulate from main memory into the cache memory? That is 32. 32 means how many bits are required? 5 bit. And what is the word size of the word offset? That is the 12 bit. That is a 4K, that is 12 bit. It means that is the logical address 19 bit, and here is also 19 bit. This is the solution of the numerical problem. We move from another problem. A digital computer memory unit 64K. This is the size of the main memory, 64K. And what is the size of each word? That is 16. What is 64K? 64 into 1024. It means 2 to power 10 into 2 to power 6. It means 2 to power 16. It means when we calculate the tag of the main memory, it means 16 bit are required. And what is the size of the cache memory? That is 1K. What is the size of the cache memory? That is 1K. What is the size of the cache memory? That is 1K, means that is the size of the cache memory. 1K means 2 to power 10 number of block are available into the cache. Now this is the main memory, or this is the cache memory, and we can calculate 2 to number 6 number of block available into the main memory and 2 to power 10 number of block available into the cache memory. Cache using the direct mapping, and in each block accumulate 4 word. Each block can accumulate 4 word. It means 2 to power 16 are divided into the 4. 4 means 2 to power 2. It means 2 to power 2 here is also divided, and here is also divide 2 to power 2. Then how many number of blocks are available into the RAM and how many number of blocks available into the cache? 2 to power 14 blocks available into the cache memory and 2 to power 8 blocks available into the main memory, so cache memory. How many bits require tag, index and block word in the field of the address format? In each blocks of the main memory, how many number of word? 4 number of word, that is W1, W2, W3 and W, and here and so on. Then what is the format of the address in the main memory? How many number of blocks are available into the main memory? That is 2 to power 14. It means 14 bit are required. And what is the size of the word offset? That is the, again, in each block 4 word are consumed. Then that is the what is size of the 2 bit are required. Now this can be accumulate into the main memory. Then number of the blocks are available into the cache memory, that is 2 to power 8. Then what is the size of the tag? 8 bit. And what is the size of the word? Word format is same. Here is also in each block can one number of bases. It means W1, W2, W3 and W4. 1, 2, 3, 4 and W4 here. Then size of the word format is same. What is the size of the index format? Index format means in each block how many number of pages can accumulate into the main memory. Here 2 to power 8 number of block, here 2 to power 14 number of blocks. It means in each block can accumulate 2 to power 14 divided by 2 to power 8. It means 2 to power 6 number of blocks accumulate into the single pages. It means what is the size of the index? That is the 6 bit. That is the format of the cache memory. This is the format of the main memory. This is the format of the cache memory. This is the format of the main memory. In GATE examination mainly asks what is the size of the tag into the cache memory, what is the size of the index bit into the cache memory, and word size is common for the main memory and cache memory. Especially GATE examination such type of the question are asked. How many bit are required in word in cache base? This question is also asked in the GATE examination. Same 2 bit required for the cache. Valid bit, if data is available then it is known as the valid bit. If data is not available, that is known as the invalid bit. How many number of block can accumulate into the cache memory? 2 to power 6. Again this question is asked in the GATE examination and university, same. Both 2 to power 6 number of blocks can accumulate of the main memory into the cache memory at the same time. Okay. Now this is such kind of the different type of the question asked in university many times and GATE examination also. We move from the another numerical example for the better understanding cache mapping, that is known as the set associate mapping. Now this is another example. What is the size of the cache memory? Here is given 128 number of block can be divided into the 4 set away. Now how many number of block available into the cache memory? Here is given 128 number of blocks available into the cache memory, and it can be divided into the 4 number of set 0, set 1, set 2 and set 3. It means 128 divided by 4, that is 32. Here if we can suppose that is set 0, here 0 to 31, if we can suppose here set 1, again 32 to 63, and here set 1 2, and here set 4, then how many number of blocks are available in set 4? In each set 32 number of blocks available in cache memory. In each set 32 number of blocks available into the, this is the configuration of the cache memory. Now the main memory consists of this number of blocks. The main memory consists of this number of blocks, and each block contain 256 8-bit word. In each block contain 256 number of word in each block. It means what is the actual size of the main memory? This number of block, and each block contain 256 in each block 256 word contain in each block. Here is also 256 word contain and in each block, and how many number of block available? 102.16383 number of block are available into the main memory. Now how many bits are required for addressing the main memory? That is very simple. How many bits are required for addressing into the main memory? Main memory, the address of the main memory again divided into the two part, tag and word offset. What is the tag? The number of blocks are available into the main memory. And what is the word offset? The size of the each word. Number of word can be accumulated into the cache memory. 256 number of block, it means 2 to power 8. That is the 8 bit of word offset of the main memory. And if we calculate this figure into 2 to power n format, then that is the number of bit. I think 2 to power 16, 2 to power 16 or 17, I can easily calculate what is the value of 2 to this value to 2 to power 16 bit, it may be. You can calculate this figure into, you can calculate this value into 2 to power n format, then that is the size of the tag bit into the main memory. We can calculate this is the 16 bit. Now the one question has been complete. Now how many bits are needed to represent tag, set and word offset filled into the main memory? It means this each pages we can accumulate into the cache memory. Then that is very simple. The size of word offset are remain same, that is the 8 bit, and the tag are divided into the two part. One is tag and another is known as the index, and 16 bit are divided into the two part. It means this number of pages are accumulate into the 120 number of the block. It means that is very simple. 16384, 16384 384 divided by 128. That is 28. It means it means 28 number of blocks can accumulate in each block. How many set into the 4 set? Set 0, 1, 2 and 3. And how many number of blocks are available into the main memory? That is 0, 1, 6, 3, 8, 3, 8, 3. It and 128 blocks can accumulate in each block. And what is the word size? 256. And in each block can accumulate 128 number of block of the main memory into the cache memory can accumulate. Okay. Now, what is the format of the tag, set and word of format into the cache memory? What is the size of the cache memory? 128 bit. That is the represent the size of the tag. And in each block, how many number of word can accumulate? That is 128. Here 128, 7 bit. And what is this? 8 bit. And here is also, what is the total number of size of the cache memory? 128, it means 7 bit. And here is a 7 bit, 7 bit, 8 bit. That is the format of the tag, index and word offset. This is the another important questions has been solved. That is the size of the tag, this is the size of the setter and this is the size of the word offset. Now, for better understanding, next class I meet you another numerical examples. Thank you.